Okay, this video is about what happens to the different parts of a circle with a central angle when it is scaled. So we're going to talk just generally without any numbers here about what happens. So say we have these two circles here, and they have a central angle, and we are going to scale them with a scale factor S. So I have dilated this small circle into this big circle, and I've dilated all the parts of it. The two radii, the central angle, and the arc length. So first, let's talk about the central angle. When you do a dilation of any scale factor, the central angle, the measure here of this angle and the measure here of this angle are the same. So dilating with a central angle has no change to the angle measure. So the central angle stays the same. The radius. So let's think now about the radius. So if we have a radius length here, R, sorry, it's on a weird angle, and we have a radius length here, R, we can see that it definitely has changed. So the radius changes by the scale factor of S. So if you took this small r and you multiplied it by the scale factor, you would get the larger r over here. So the radius changes by S, the scale factor. All right, let's talk about the arc length. So that's this labeled here as lowercase l and this labeled here as uppercase L. So the arc length also changes by the scale factor of S. So if you looked at this smaller arc here, lowercase l, and you multiplied it by the scale factor S, you would get the larger L over here. As we saw from our experiments in class, the area of the sector, so that would be like this whole area here, this whole area here, actually changes by S squared. So that's because when we take the radius here, if you look back, so the radius, right, the larger radius is equal to the smaller radius times S. When we square those, when we plug it into the area formula and we have R, large R squared, that means we have small r squared and small s squared. So if you were going to do the area of the small one, you would actually multiply it by s squared to get the area of the larger one. Because of that, because this changes by a different factor, we're going to talk about comparing the arc lengths and the radiuses, since those change by the same factor. So the last thing I want to look at is the ratio. This ratio is going to turn out to be extremely important in our class, of arc length divided by radius. So if we look at the small circle here, arc length is L, and we divide it by the radius R. And if we look at the larger circle here, that would be, I'm going to do it in a little thought over here, large L divided by R. And since we know that the L of the length here of the large circle is equal to the small circle times the scale factor, and we know that the radius here of the large circle is equal to the small circle times the scale factor, we can replace capital L over capital R with these two things that they're equal to. Hopefully we've noticed here that we are just multiplying L over R times S over S, which is 1. So these two ratios are equal. What that tells us then, that should be a uppercase R. What that tells us then is that when the central angle stays the same, for all of central angles that are the same, the arc length divided by the radius is always equal.